Now the domain of a function is a set of all x coordinates of every point on the graph of that function. So this function has infinitely many points on its graph, and so we can't just list out all of the x coordinates. We're going to give our domain as an interval, which is going to go from least to greatest. And so we see a couple of things here that are going to make it so that we cannot just plug any real number that we want in for x. For example, if I plug a 10 in for x, I would get on the bottom here the square root of 24 minus 30. 24 minus 30 is negative 6. I'd have the square root of negative 6, which is an imaginary number. So I need to make sure that 10 is not in the domain. So I don't want to be able to plug a 10 in for x. I don't want any imaginary numbers as my outputs. So one of the restrictions here is going to come from the fact that we've got this square root. Another restriction is coming from the fact that we have this division, or this fraction, and we have a variable in the denominator. So dividing by 0 specifically is undefined, and so we want to make sure that we don't plug in anything for x that would make the denominator 0. Let's go ahead and deal with our square root first. Anytime we're finding the domain of a function involving a square root, we need to take that expression that's inside that radical, in this case 24 minus 3x. So just write that part that's inside, don't include the square root on that, and set that greater than or equal to 0. What we're saying there is that we're making sure that the number that we're plugging into that square root is something that will give us a real number answer. We're basically saying that this is not negative. Negative would be less than 0. So we want to take it and make it greater than or equal to 0. And that way we're ensuring that we get a real number answer. Now, being that this particular square root is in the denominator of the fraction, and that we also, as we just mentioned, cannot divide by 0, dividing by 0 is undefined, in this particular case we do not want this to be equal to 0 either, because that would result in having a 0 on the bottom since this expression is on the bottom. So if we just simply take off that or equal to part, then that will go ahead and cover both of our restrictions. And so what we need to do then to complete our solution here is to just go ahead and solve for x. So I'll just go ahead and subtract 24 from both sides, and then divide by 3. Now remember, with an inequality, whenever we multiply or divide both sides by a negative, we need to flip that symbol. So here I get x is less than positive 8. So that's essentially my domain. So as an interval, if I go ahead and maybe graph it first on a number line real quick, we'll be able to see the interval a little more easily. Less than 8 would be from 8 and going to the left. So if I write that as an interval going from least to greatest, I'd start at negative infinity, and I would end at 8, and I would not include 8, which I'd indicate with parentheses around it. If we were to include 8, that would make the denominator 0, in which case the entire fraction then would be undefined. So we're not including 8 so that we can avoid that. And if we plug anything in bigger than 8, like the 10 I mentioned earlier, that would lead us to an imaginary number, which we also want to avoid. So you'll notice that we did not take into consideration the expression in the numerator for the domain, and that's going to be the case for any function. The domain's not going to be affected by anything that's in the numerator, unless, of course, we have a square root there.